Almost. Oh, we're live. Good. Okay. Cool. Here we go. So today it is 1/7/2020. Okay. Today's objective. It's called a phase shift, but what we're going to do, so it's called a phase shift. What that means is this: we're going to move horizontally and vertically y equals sine theta and y equals cosine theta. Okay? We're going to move them. So we're going to do a phase shift. So how do we move them? Well, here's what I suggest. Let's graph the original and then move it. So my suggestion is this. Okay? First, let's graph y equals, in this case, 3 sine of 2x. Okay? So what I'm going to do is ignore this pi 8s. So I'm going to do this problem in 2 steps. Okay? We did this part yesterday. Okay? So I'm going to take my sine graph, and then after I put it down, I'm going to move it pi 8s. Okay? Boom. Okay? That makes sense? I'm going to graph this graph. We did this yesterday. I'm just going to put it in, take it, and move it. Boom. So I'm going to do it in 2 steps. So how do I graph the original? Well, I'm hoping you guys know that, but we'll see. So here's what I know. My amplitude is 3. So if it's 3, I'm going to go, okay, 1, 2, 3. 1, 2, -3. Okay, I'm going to do that. Autumn, yes, a really good question. How do I know what to put here, right? So to find the period, the new period, we're going to take 2 pi, always, because these graphs are always 2 pi wide, right? The standard basic graph is always 2 pi, and the reason it's always 2 pi is because we took the circle and rolled it, right? Always 2 pi. And then we divide this by the frequency. So the frequency is 2, right? So divide by 2, because that's my frequency there. And if I do divide 2 pi by pi, I get 2 pi by 2, I get pi. So here's what I know. I need one graph in pi, and my second graph in another pi. So I get 2 curves, okay? So when I'm thinking pi's, it's not pi thirds or anything like that. So let's just put down our normal stuff like our 0, our pi fourths, our pi halves, 3 pi fourths, and we'll get pi, okay? So I'm going to put down my normal, so I'm going to go pi fourths, I'm going to put down pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. So I'm just putting down, from what we did yesterday, the main angles. The angles pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, back to pi, okay? Now, those are my points. So what I do is I say, okay, well, I want to graph a sine. What does it look like? So I want to take this shape here, and I know a sine curve looks like this. Okay, that's the sine. I'll take this shape and put it between 0 and pi. Or this shape right in this space here, okay? Okay, because I want my new period is pi, so I'm going to put that space there. So 0 to pi gives me 1 curve, pi to 2 pi gives me 2 curves, my frequency is 2, and I get 2 in there. So how do I do that? Again, I like to look at my 5 special points. It really has a beginning, has an end, both of which are at a height of 0. It has a middle spot, and the middle spot has a height of 0. It has its height, its tallest spot, which is going to go up to 3. It has its lowest spot, which is going to go down to -3, okay? And I'm going to put that within this little space in here. Okay, so, all right, let's do that. So I'm going to go, all right, I'm going to go 0 for the beginning. Pi is the end. Pi halves up here, down here. And I'm going to sketch it in lightly, okay? So sketch it in lightly because I'm going to move this graph, okay? So I've got 1 curve, and I'm going to do the exact same pattern, but on the second part, so I get 2 curves. So I'll take this shape again and put it right there. It starts at 0. It's going to end at 0. Halfway through, it's going to be at 0. It's going to have a height of 3 here and a height of -3 here. And again, I'm going to draw that in very carefully, okay? There it is. Now I'm going to do my phase shift. I'll let you catch up. So what I have is 1, 2 sine curves, which is what I want. A height of 3 down to -3 because that's my amplitude, okay? But the last step is to move it. I'm going to do a phase shift. So if it's negative, I'm going to move it the opposite direction. So instead of moving it back, I'm going to move this forward pi8. So my phase shift is to move it forward or to the right pi8. Okay? Now, let's take a look at my graph. How much is pi8? Well, that's why I like graph paper. Okay? And I know yesterday I was fighting with some kids in 3rd period to use the graph paper, and they're just slopping it down. But graph paper is really going to help because in my graph, I know that pi8 is 1 square. Right? I mean, if this is pi fourths, then pi8 is 1 square, right? So this is really pi8. And that's why I like to use graph paper because it really helps me get my spacing correctly. So then I'm going to take every important point. And this has got 5 important points, right? And I'm going to just move every important point forward pi8, which is 1 square. So this point goes here. This point goes here. This point goes here. So every important point, so just basically taking the graph, and I'm just going to go pick it up and move it, boom, over 1 square. That's all I'm going to do. Take the whole graph, boom, over 1 square. But I'm going to do it point by point because it's easier if I do it point by point.
Why would you shift that?
If it's a positive, it's going to go the opposite direction, right? Good question, though. Okay. Always question what I do, right, Caden? Because I do make mistakes, right?
Sure.
Right, Lily? Like, instead of writing degree, I wrote radians, right? Okay, so I'm taking every one of my important points, and I think these 5, the x-intercepts and the max and the mins are my important points. Okay. Now, all I got to do is just draw it in. There's my sine curve. Okay. There's my sine curve. I've got 2 of them, don't I? I've got 1, 2 of them. It goes from 4 to -4, and I shifted it pi8. All right? Let me make this thumbs up. So here's my answer. I'm going to make it a little bit darker. Here's my answer. And of course, it keeps going on and on and on forever. Okay? How's that? I did 3 things. I made it have an amplitude of 3. I have 2 curves in the space of 1, and I shifted it pi8. Thumbs up. Okay, let's take a look at number 2. So number 2, I've got a negative cosine. So if it's negative, it's going to be upside down. So there's a few things I want to do. So the negative is going to make it a reflection over my x-axis, or it's going to be upside down. Okay, so the negative means this. My cosine curve is going to be upside down. Okay, so in this case, boom, right? But I'm going to go cosine. The second thing I know is my amplitude is 4. Amplitude is always a positive number. Does that make sense? Even though it says -4, amplitude is like how big is the wave, right? Right? How big is the wave? And then the period. Whoops, sorry. The period. Well, how do we find the period? The period is always 2 pi divided by the frequency. Well, there's an invisible number right here, 1, right? So my period is just 2 pi. So I want 1 curve in 2 pi. 1 curve, right? So I know cosine looks like this. This is what a cosine curve looks like. It starts up. That's what a cosine looks like. But we're going to do a negative cosine, so our cosine is going to look like this. Okay, that's the shape I want. So I made it upside down because it's negative, okay? So I want that shape. I want that shape between 0 and 2 pi at a height of 4 and down to -4. And then after we graph that, we're going to move it. So I'm going to graph first. I'm going to graph a y equals a negative 4 cosine of x. All right, so, all right, pi force, pi halves, 3 pi force, pi, I've got a 5 pi force, a 3 pi halves, a 7 pi force, and a 2 pi, okay? Once I start recording, Seth, I can't zoom in. I guess you guys could always sit closer, but once I start recording, it won't let me change.
What's the one before pi?
Okay, so it's all of these. You ready? It's 0 pi force,
Oh.
pi halves, 3 pi force, right? Pi, 5 pi force, 3 pi halves, 7 pi force. How's that, Julia? It's these, okay? And we'll only change that if we have thirds. Does that make sense? Only if it's thirds. Okay, now I want this shape right here. See this really funny look of an upside down curve? I want that shape here. Does that make sense? I want this shape here. Okay, from a height of 4 to negative 4. So we put my 4 to negative 4 in there. 1, 2, 3, 4. 1, 2, 3, 4, okay? So I'm going to draw it in lightly because I'm going to move it, okay? So I know that cosine has its 5 important points. It really does. It's got its beginning, which is down, right? It's got its end, which is down. Its middle is all the way up. 1/4 of the way it goes through 0, and 3/4 of the way it goes through 0. So those are my 5 important points. Let's see if I can put those on here. So it's going to start at negative 4, right? And it's going to end at negative 4, but we don't put the whole thing in 2 pi, so it's going to end. So I'm going to put one curve within this region here. So I'm going to end it here. Oh, let me get it. Actually, I want black. And it's going to end here. Halfway, right? Halfway point. Pi is halfway. It's going to be up at positive 4. 1/4 of the way, it's going to be at 0. Well, that'd be at pi halves. 3/4 of the way, it's going to be at 0. So that's going to be at 3 pi halves. Okay. So if I lightly sketch it in, it's going to look like this. Okay. And there is one upside down curve. It's upside down. It's an upside down cosine curve, and it goes from 4 to negative 4. Okay. And just got one in it, right? 1 because the frequency is 1. Okay. Now we're going to move it. Now it gets easy, because moving is easy because we've got our important points. So we're going to do a phase shift. So we do what we call a phase shift. We do a phase shift of pi force. But we're going to go backwards. Because it's a positive, we're going to go back pi force. We're going to go to the left, okay? So I'm just going to take my important points, right? And I'll move everything back pi force. So pi force is 2 squares. That's why I like graph paper, because the graph paper makes it nice. So every point just goes back 2 squares of pi force. So this point goes here. This important point of pi halves, it goes back pi force. This point goes back pi force, which is 2 squares. This point goes back 2 squares, which is pi force. This point goes back 2 squares, which is pi force. So then my final answer is this curve here. And I'm going to just extend it because it goes on and on and on forever and ever through this wave. Okay? That's not so bad, is it? Right? You guys want to turn the page? If we turn the page, then we're going to do both. Okay? Okay? And I might need a different page because that bled through. That's okay, I can do that. Do my notes on 2 pages, huh? Okay, now, example 3. Are you ready for example 3? Okay, we got to do 2 things. Here's my dance. Okay? We're going to move it, pi force forward, and then we're going to take it down 1, okay? But that's not that bad, because we'll do that as the second step. So before I do anything, let's put the curve, the regular curve. Before we move it, let's graph this. So first, I'm going to graph y equals 3 sine of 2x. I'm going to graph that first, okay? So what's the period? Well, the way we find our period, it's always 2 pi, always divided by your frequency, okay? Okay. The period is how wide is my new curve? How wide is my new curve? Well, it's going to be pi. So I'm going to put one curve in pi and the second curve in pi to 2 pi, okay? What's my amplitude? It's 3, right? So I'm going to go 1, 2, 3, 1, 2, 3, and then -3. And then I'm going to just put in for my x-axis my angles. Pi force, pi halves, 2 pi force, pi, 5 pi force, 3 pi halves, 7 pi force, and 2 pi. So I'm going to put those on my axes. So I'm going to do that now. Go pi force, pi halves, 3 pi force, pi, 5 pi force, 3 pi halves, 7 pi force, and 2 pi. Okay, tomorrow we're going to learn why anybody uses this stuff. We're going to look at some applications on this tomorrow, okay? And then Thursday I'm going to bring in an oscilloscope and we're going to sing into the oscilloscope and you're going to see a sound wave. It's going to be kind of cool. Really well. We're going to see. I'm going to let Isaac sing into it so we can see perfect. We can see perfect pitch.
No, I don't see no more.
All right, we'll bring Landon in then, huh?
There you go.
There you go. Okay. Isaac has a very nice voice. He's just not going to admit it.
He sings me to sleep. I
He
do not
has a very nice voice. Okay, so you ready?
read the same.
So I'm going to put in from my sine curve. My general sine curve looks like this. This is what a sine curve looks like. That's one sine curve. Remember doing sine curves, Emma? Oh, yeah. Okay. So, Celeste, I got something for you, okay? When you're ready right now. So, I got to put this shape between 0 and pi. Does that make sense? Because I know that I've got my period of pi. So, let's put this shape in, okay? And it's going to go up 3. So, I know it starts at 0, right? Okay, it starts at 0. It ends at 0. In the middle it's at 0, right? At the max is here and the min is here at 3, so my curve looks something like this. I'm going to put it in lightly because I'm going to move it. Okay, there it is, right? I'm going to do that exact same pattern, this shape again, but here, okay? So it starts at 0, ends at 0, in the middle it's at 0, 1/4 of the way it's up at 3, and then down at -3, okay? Starting to catch on. This is getting a little bit easier, okay? Now, after I put the basic shape in, we're going to move it, okay? So we're going to move this thing. We're going to move it pi force forward, pi force to the right, and then we're going to move it down 1. Okay? So if I do that, all I'm going to do is take every important point and move it pi force. Now, pi force is 2 squares, right? You guys see that? So I'm going to move everything over 2, down 1. Every important point is just going to move it over 2, down 1, because I'm going to move it pi force, and that's pi force, 2 squares, and then down 1, okay? So let's just do that. So take every important point, I'm going to move it over 2, down 1. So the graph is getting shifted. Over 2, down 1. Over 2, which is pi force, down 1. Over pi force, down 1. To the right, 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 pi force, down 1. Okay? So I've shifted it. Take the whole graph. I've basically picked it up, point by point. I picked it up, moved it over 2, down 1. It's all done. Now I'm going to, over 2, over pi force, down 1, right? Okay. Yeah, and now I'm going to go ahead and draw in my curve. So my curve got moved right there.
Why did you move it over to?
Really good question. So I want to move it pi force.
Well, yeah, I get that you're saying pi force.
But in my axes, for my graph, because you can put your axes any way you want, Autumn, but in my graph, my axes, 2 squares is pi force. Does that make sense? It's just the way I did my scales, okay? Somebody else might have done different scales here, but the way I did my scales is pi force is this much, which is 2 squares, okay? All right, last but not least, okay? Now, let's take a look at this one. So, first of all, before I do anything, I know I want to take a look at what a cosine curve looks like. A standard cosine curve looks like this. So I want this shape. I want this shape. But I want this shape an amplitude of 4. So I'm going to go 1, 2, 3, 4. And -1, -2, -3, -4. Okay, that makes sense, right? Now the period, before I even put anything down, because Autumn, forgive me, Autumn, I'm going to change this one again. So my period is always 2 pi divided by the frequency. Well, what's the frequency this time? Pi, right? So if I divide 2 pi by pi, I get 2. Okay, now this is kind of weird because I'm not going to have any pi's here. I'm going to go 1, 2, 3. Now this is a true application in physics because when we're talking about a wave, we're talking about time. And time's not going to be in pi's, time's going to be in seconds, correct? So let's just say, Jay, did you get the homework? Okay, there you go.
I guess, yes.
So then I'm going to go 1 second, 2, 3, 4, and 5, and so forth and so on. Now, probably what you've noticed, and I think you know why, is I always go every 4 squares. And you know why I go every 4 squares, don't you? Because of my important points, right? And I always go 4 squares, because when I have 4 squares, I get my key points. Remember my key, my 5 points I like to move? So then from here, let's take this shape. Y equals a 4 cosine of pi x. Graph that first, and then we'll move it. Okay, so first, let's try and put this graph in here. Okay, so let's see. It's going to start up at 4, right? It's going to have a width of 2. It's going to have a width of 2. So I'm going to go ahead and start at 4. It's going to end at a height of 4. The very middle of the cosine curve, it's going to be down at -4. Halfway through, it's at 0. 3/4 away, it's at 0. Okay, so my first cosine curve looks like this. Nice and curvy. And again, you know it's not going to look perfect because I'm going to move it. Okay? And I'm going to do another one because I like to have at least 2 of these because it goes on forever. So the same shape again. It starts up at height of 1 or 4. And it ends at a height of 4. Halfway through, it's going to be down at -4. 1/4 away, it's going to be through 0. 3/4 away, it goes through 0. And I'm going to go ahead and just sketch that in. Okay? There you go. Now, let's move it. We're going to move it. How are we going to move it? I'm going to take it and move it to the right 2, and we're going to move it down 3. It's the opposite of the side, right? So we're going to go to the right 2. So every important point is going to go to the right 2 and then down 3. Okay, now I got to be a little careful because my scales are weird, huh? So so if I have to move it to the right 2, right, then 2 units is to here. So that means this point moves to here. Oh, I like that. I like that. Do you know why I like that?
Because we can just start along the end.
It moves right onto itself, doesn't it? Doesn't this go boom to here? I like that a lot. It moved right onto itself, didn't it? So this curve is going to go here. Boom. And you're right. This curve is going to go here. And the curve that's back here, which we didn't draw, is going to go there, right? So what do we got to do? So we also have to move it down, right? So let's take every important point and move every important point down 3. So really, if I move everything down 1, 2, 3, it's already been moved 2. Okay, this point here goes to here, and then down 3, right? This point right here goes to here, and down 3. I like it. It shifts onto itself. All right, so I'm going to go down 1. Oh, you don't have to go over because it's already been done. Oh, down 3. Down 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and then I'm just going to go ahead and draw it in. It keeps going on and on and on and on. Here we go, make it darker. Okay, here's my answer. What do you think? Okay. All right, before I finish, let me go ahead and stop this.